you can use Pythagoras' theorem to test a right angle. So I've got a couple of triangles here in front of me, and I want to know if these are indeed right-angled triangles. Now, they've not been drawn to scale, but I do have the measurements, and the measurements have been rounded to 1 decimal place. So what I'm going to do is I'm going to work out, using Pythagoras' theorem, what the hypotenuse should be given these two shorter sides. And we're going to see if it gives us what we're expecting. Okay, if it doesn't, then it's not a right-angled triangle, because Pythagoras' theorem only works for right-angled triangles. So let's try the first one here. So we've got the shorter sides squared and added together, and that should equal the longer side squared. So if I square root it, it should equal this longer side. So if I type this in my calculator, what do I get? Let's have a look. 4 squared plus 6 squared, square root it, and I get an answer of 7.2 if I round it to 1 decimal place. Now, 7.2 is not equal to 8.5. So this triangle here is not a right angled triangle. Not right angled. Okay, let's try the next one. So the next one, so I think this looks like it's going to be the right angle there. So my two shorter sides will be 5 and 6. And so I'm going to write down what Pythagoras' theorem would be. So I'd do 5 squared plus 6 squared, my shorter sides squared and added together. I'm going to square root it to find out what the longer side would be and see what that gives me. Oops, what does that give me? Let's have a look. Type it in my calculator. 5 squared plus 6 squared, square root it, and I get an answer of 7.8. It goes on, but if I round it, it goes just to 7.8 to 1 decimal place, and 7.8 is the same as 7.8. So this is a right angle triangle. So I can give that a lovely tick. This is right angled. And that is how you figure out if you have a right angle or if you've got a right angled triangle.